Now that we've talked briefly about the basic Java completable features, let's go ahead and see how you can apply these features in practice. And we'll do this in the context of operating on big fractions. We've talked about big fractions before. It allows arbitrary precision, big fraction arithmetic. And then, of course, we'll round this up with a discussion of why these basic features are limited, and they're pretty much limited for all the same reasons that the basic features of Java Future were limited, because they're not much more than the basic features of Java Future, just a few extra things that are added. So here's the example we're going to do. We're going to multiply big fractions with a completable future. And you can find this example in my EX8 folder. And I also have a little diagram over here on the right-hand side that kind of walks through what's happening as we look at the code, just to give you a higher level perspective on this. So the first thing we do is we make ourselves a new completable future that is intentionally incomplete. There's no computation associated with it. And that's just basically like having the main thread call new on the completable future class to make an object of completable future. We then go ahead and start a new thread. So this is a background thread, and we're going to make a new thread, and we're going to start that thread. And that's going to perform computations in the background. All that means is it will not block the calling thread, the thread that created it, which in this case is the main thread. Then we're going to go ahead and perform some computation inside of this background. As you can see, that's what's shown here on the interaction diagram by the ... next to this little loopy arrow. And what we're going to do is we're going to create two big fractions, BF1 and BF2, and we're going to go ahead and multiply BF1 by BF2. So these two computations get multiplied using the big integer mechanisms under the hood. That's all taking place in the background. Meanwhile, the main thread, ... is doing something else. Now, if the main thread is not doing something else, then there's really no point in creating a background thread and running some computations in it, because we might as well just do it in the foreground thread. So the whole purpose of doing these things is to get something off of the main thread so it doesn't block the main thread, so that we can do other things in the main thread. And right now I'm just leaving it out, but you could imagine doing other things. You could do other computations, you could wait for user input, you could be balancing a B tree, whatever you're doing something in the foreground while background stuff is taking place in the background. Or you're being responsive. That's probably the best way to look at it. At some point, the background computation is done, so the background thread is going to call complete on the completable future with the results of multiplying BF1 by BF2. As you can see over here on the right-hand side, that will trigger the complete call on the completable future from the background thread. And then at that point, or whenever complete is called, after complete is called, then if the main thread happens to call join, that will then get the result back. So if it's still doing ... stuff before complete is called, then after complete is called, when it calls join, it'll get the result right away. If it happens to finish its ... stuff before the complete is called in the background thread, then when join is called, it will block until complete is called by the background thread. Hopefully that's pretty clear. That's just a classic example of the use of futures. And then the last thing we do here is we convert the result to a mixed fraction and we print the result. Okay, so it works. It's pretty simple, but there's problems. And the main problems here are all the same problems we saw with futures when we talked about a few lessons ago. You can't chain them together fluently. You can't trigger them reactively. You can't have them be treated efficiently as a collection of completable futures. So there's lots of limitations, basically the same problems we saw before. And just another point here, we call join, so we're blocking. Whenever you block, whenever join is called, something is probably gone amiss. There are situations where you absolutely have to call join. Like if you need to get a result before you can display it to the user. You may eventually have to say, okay, I've done everything else I can possibly do. I've got to give the user a result. I'm now going to join and wait for however long it takes to get that result because I've run out of everything else to do. But that's always sort of the last resort. You want to call join sparingly, and that's because it ends up underutilizing cores and increases overhead in many ways. Moreover, using a timeout, we already discussed you can't have a timeout for join for some God knows what reason. You could use a timeout with get, but that's also got its own set of headaches as well. So as you see here, if you're going to be using timeouts with completable futures, something has gone wrong, most likely, and that's true for futures in general. So therefore, if we really want to get our bang for our buck, we need to use these basic features very sparingly and instead focus on using the advanced features of Java completable futures, which of course is what we're going to cover now.